So here are 4 examples that are a little bit more complicated. All of them require us to use multiple rules. Now let's look at the first one here, 27x to the power of 3/4, all to the power of 2/3. The first thing I'm going to do is use my power of a power rule to note that 2/3 applies to everything inside my parentheses. So I have 27 to the power of 2/3 multiplied by x to the 3/4 times 2/3. So next, I'm going to write 27 to the 2/3 as a radical expression. And I'm going to multiply the numerator and the denominator of my fractions that are the exponents of my x term. So 3/4 times 2/3. Great, so let me think for a minute. How could I rewrite 27 to the power of 2 so that I would be easily able to see cube root factors? Well, I do know that 3 to the power of 3 is another way to write 27. So I could write 27 squared as 3 to the power of 3 squared. Let me rewrite that one more time. Now I'm going to write it as 3 to the power of 6. And when I actually write out 3 to the power of 6, I see I've got 6 3's multiplied together. And I want to pull out groups of 3 3's. So I have 2 groups of 3 3's. So that means that the cube root of 3 to the power of 6 is 3 squared. And now this time, instead of writing x to the power of 6 over 12, I'm just going to write x to the power of 1/2. I can simplify this a little bit further by writing 9 instead of 3 squared. And then I'm just going to keep my x to the 1/2. There we go, simplified. Let's look at the next one. So I think on this next one, I noticed right away that I have 2 radicals that both have an index of 3. So I have 2 cube roots here. I'm going to rewrite them with 1. Since they both have the same index, I can put these together. I know that they'll be multiplied underneath the radical. So now I just did a little bit of multiplication and simplified my inside there. And this is nice because I know the cubed root of 8. The cubed root of 8 is 2. So I'm going to move a 2 outside. And I know the cubed root of y to the power of 3. The cubed root of y to the power of 3 is just y. So I'm going to move that outside as well. So now the only thing left in my cube root is the x squared. Now I would really only like to have one x term in my expression, so I'm going to go ahead and rewrite that with a rational exponent. So I'm going to write this as 2xy times x to the power of 2/3. That's just another way of writing my radical expression there. But now I can put these two x's together. So 2xy times x to the power of 2/3 could be written as 2x to the 3/3 times y times x to the power of 2/3. Why can I do that? Well, because 3/3 is just another way of saying 1. And what I had was really x to the power of 1. So now let me add my fractions together, and I end up with 2x to the 5/3 y. So we did some multiplication. Now let's look at some division examples. So in this bottom left-hand problem here, I see that I have an x in the numerator and an x in the denominator. So using my quotient of powers rule, I know I'm going to be subtracting their exponents. So I could rewrite this entire expression like this. I don't even need to write a denominator now. I know that x to the 1/3 divided by x to the 1/6 is x to the 1/3 minus 1/6. So let's get a common denominator for those and subtract. So that one wasn't so hard. Sometimes rational exponents are actually easier than square and cube roots. Let's remember that looking at this next problem. My first step over here is going to be to rewrite these both using rational exponents. So in this case, rewriting using rational exponents lets me see that what I really have to start with is a subtraction problem. I'm going to be subtracting my fractional exponents, specifically -2/4 minus -9/6. A little bit of simplification can help here. For example, -2/4 is the same thing as -1/2. And instead of subtracting -9/6, I'm going to write that I am adding 3/2. And look, now I have a common denominator as well. So let's go ahead and add these together. This gives me 2 to the power of 2/2, or that's just 2 to the power of 1. So 2. So that entire expression was just a fancy way of writing the number 2. So now that you've looked at some examples of complex radical expressions, you're ready to do some on your own.